Hello. Today's video, we're going to learn about special quadrilaterals properties. We're going to learn how to identify special quadrilaterals based on their properties and be able to create special quads and triangles using mathematical reasoning. I'm going to go through 7 total today. We're going to look at a diagram for each and then go through each symbol and property that is going to appear in the diagram for each special quadrilateral. Some of them are going to be repeat. Like the first page here, we have some shapes where we have common properties with some small differences. I'll talk about those when we get there. The first shape is a parallelogram. That's simply going to be a quadrilateral with opposite sides parallel. If at any point during the video you need to pause to catch up, go ahead and do that. What else is true? Opposite sides are also congruent as well as parallel. So they have the exact same length and they're parallel in nature. Opposite angles are congruent as well. So now if we're looking inside the figure, the angles that are opposite each other or across from each other are also congruent. Consecutive angles are supplementary. The word consecutive, remember, means to be adjacent or next to each other. So the angles that are right next to each other in the quadrilateral are going to be supplementary, so they add up to 180. This is the diagram I have for parallelogram. As you can see, there's a lot of information on it. So when you're looking at this, some things to notice. First of all, arrows indicate parallel lines. So these two sides both have one arrow. These two sides both have two arrows, indicating that these two sides are parallel and these two sides are parallel. Also, the tick marks. One tick mark here and here. These two sides are not only parallel, but they're congruent. And the same thing over here, 2 tick marks for these two sides. Inside the diagram, we have angle markings. A and C are opposite angles, and from here we know they are congruent. D and B are opposite angles, and again, same thing, they are congruent. They both have two arc marks in order to indicate that B and D are both the same. Now, moving on. A rectangle, not rhombus. A rectangle is a parallelogram, so it has all the exact same parallelogram properties, and the one extra thing it has is that the angles are congruent. All the angles are exactly 90 degrees. So everything we just said for parallelogram goes for a rectangle. So as you can see, it's got the similar markings. The only change here is that instead of the arcs, I have 4 90-degree angles because all the angles are congruent. So sides are parallel, sides are congruent, and consecutive angles are still supplementary because 90 plus 90 is also 180. So that's rectangles. You need to pause it, catch up, you can. Moving on down to here, the third shape we have is a rhombus. This quadrilateral is a parallelogram with this change. All sides are congruent. So it's a parallelogram, so everything I said for the first shape, except that the sides have to also be congruent, all 4 of them. So it's kind of like a square that's been tilted, you could say. So as you can see, the tick marks here, every single tick mark is the same number. It's 1 tick mark for each side, indicating that all 4 sides are exactly the same. Angles that are opposite are congruent. A and C, D and B. Opposite sides are parallel, and the same goes for consecutive angles. They're going to be supplementary as well. So you need to catch up, pause it, copy it down. The back side of the notes, we have 4 more shapes to do. A square is also considered a parallelogram, except it has 2 things past that. It's also a rectangle and a rhombus, meaning that the parallelogram has to have all angles congruent and all sides congruent. And if that's true, what you create is a square. We have 4 equal sides, 4 equal angles, sides are parallel. That's a square. So pause and catch up if you need to. Now, the last 3 are the, don't want to say weird, but maybe uniquely shaped quadrilaterals. A kite, probably something you've drawn when you're doodling or maybe you've seen before in a cartoon. A kite's a very simple shape, but it's got a weird look to it. It's not a parallelogram where opposite sides are congruent. We actually have consecutive sides that are congruent. So instead of ones that are opposing, like a rectangle or parallelogram, are congruent, They have to be right next to each other. So what that does is it creates this shape where you have two shorter sides and two longer sides for the kite. So you have one pair there and one pair here, and they're right next to each other. So just to contrast this, that's a parallelogram. As you can see, the tick marks that match are opposite each other. The kite has them right next to or adjacent to each other. There's also exactly one pair of opposite angles congruent. These two right here that are in between the two sides that are different, those two angles are actually congruent. Not these two over here, but these two are. Last couple are pretty close together. They are trapezoid and isosceles trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So if it has more than one pair, then it's going to be a parallelogram. But if it has exactly one pair, we have this. One pair of parallel sides, a pair of non-parallel sides, and you have exactly two pairs of consecutive angles that are supplementary. You'll notice that these two angles here and here, 120 and 60, when you add those together, you get 180 degrees. These two are supplementary. 80 and 100, add them together, you also get 180. They are also supplementary. That is because if you were to extend these lines out, you should start to see how they're part of two parallel lines and a transversal. Those are consecutive interior angles. And as we know, consecutive interior angles are going to always be supplementary. Same thing on this side as well. Here's another version of that same shape. We have a trapezoid. We have two sides that are parallel. Both pairs of angles that are essentially stacked on top of each other are consecutive. They are supplementary. 70 plus 110 is 180. 90 and 90 also makes 180. The last quadrilateral is going to be a special case of a trapezoid. It's called an isosceles trapezoid. And as you know from our triangle notes, isosceles means two sides congruent. And that's exactly what happens here. We have a trapezoid with the non-parallel sides, we're going to call them legs. They are congruent. So here's how it looks. You got one pair of parallel sides. Then you have these two, we'll call them legs. They're exactly the same length. They're not parallel still, but they are exactly the same length. This is probably the trapezoid you've seen the most. It's the most regular looking trapezoid, whereas a plain old trapezoid can be misshapen in different ways. This is kind of standardized where you have two sides that are congruent. It's very symmetrical. The base angles are also congruent here. So much like a isosceles triangle where you have two angles that are the same thing goes for an isosceles trapezoid where the two base angles here are congruent. So here and here congruent, here and here congruent. These two still add up to 180. They're supplementary. That's still true. They just so happen to be part of a congruent pair across the trapezoid. And that's all 7 special quadrilaterals. You have to know the name, how they look, and every single property that's listed for each of them. Okay? And some helpful tips. The parallelogram shape, that appears in the rectangle, the rhombus, and the square definitions. So if you know the parallelogram definition and everything in here, it makes the rectangle, rhombus, and square definitions a lot easier to digest. Okay? All right, so we're going to work on our practice on the following pages, and that's it for the video.